In this video we have a piecewise function h of x. It's the same function that I used in the method 1 video when we plotted these lines and then erased the parts that we didn't need. The difference in this video is that we're going to use method 2, which requires no erasing. So everything that we graph, so this line, that when we start to graph it, we'll start at x equals 2 so that we consider the domain right away. Alright, so I'm going to figure out the point. So we know that x equals 2, right? We just need to figure out where on x equals 2 we need to plot that point. So what is our y going to be when x equals 2? So I'm going to start this off by rewriting it. Y equals -3, and then I'm going to have parentheses open there and go back and plug in my 2. So let's solve this then. We got y equals -3 times 2 is -6 plus 2. So then y will equal -4 whenever x is 2. So that's going to be our point. 2. Oh man, some problems here. Our point is 2 comma -4. Now I want to plot that on my graph, and before we plot that point we have to figure out what our inequality is. Because it's also equal to, it's less than and equal to, or less than or equal to, we want to plot a closed dot. So when we plot this point, which is over 2 and then down 1, 2, 3, 4, it's going to be a closed dot. And then we want to use the slope as well as the inequality to graph the rest of the line. So now, because we know we want our line whenever x is less than 2, we want to plot the line going this way. So we don't want anything to the right of x equals 2, we want everything to the left of it. Our slope is -3, so because we're graphing backwards and not forward, we have to go up 3 and then backwards 1. Okay, so again, up 3, backwards 1, and then I'll just continue with this line going up this way. You don't want to go down 3 over 1, down 3 over 1, because we have to go backwards. So it's kind of like that. Now let's go back and do the exact same thing for our other line. So I'm going to start off by plugging in my x value. So we've got y equals 1/2 times x minus 4. Go back and plug in a +2 for our x, and then solve that. So we've got y equals 1/2 times 2 is 1, and then minus 4. So y will equal -3 whenever x is 2. So we've got our point of 2 comma -3. Okay, now we want to go back and graph this on the coordinate system. We check our inequality symbol. Because it's greater than, we're going to use a open circle or open dot when we graph this point. So let's go over 2 and then down 1, 2, 3, and it's going to be an open circle. And then we'll use our line tool to graph the rest of that line. So because it is x is greater than 2, we want everything to the right of the 2. So we're going to go from this point up 1 over 2, up 1 over 2, up 1 over 2, and I'll just continue it on this way, and that will be our line. So to recap, what we did was just take our inequality over here, whatever value's in for the x, we plug that back into our equation to get our y. That way we know where our line is going to start from. And then we use our slope as well as our inequality to figure out the direction and the rate of change of our line. So that's how we would graph piecewise functions using method 2, and there's no erasing involved.